Hello everyone. Today I'm going to talk about MARINA, which is a MLP attention model for multivariate time series analysis. As we know in time series analysis, the goal is to predict or to forecast with data in certain time frame. And because of that, there are two main features in time series, which is high in volume and low in information density. And it makes it hard for human to extract the full context because of the aforementioned features. And to better systematically analyze the data, we classify two main tasks, which is temporal correlation and spatial correlation. In temporal correlation, the main goal is to analyze the similarity and the dependency between historical points and future points in the time series that is concealed in the periodicity and the tendency of the data. As we can see here, temporal correlation is the similarity between data item in different timestamps. And as for spatial correlation, its goal is to analyze the similarity between different time series. As we can see here, in different dimension of the data, the tendency is similar, and we can see that we can utilize this feature to incorporate different dimensions of the data. In related work in time series analysis, there are transformers, as we can see the success in MLP field, and convolutional neural network, and recurrent neural network, which is originally designed for time series analysis. Last but not least is MLP model, which stands for multi-layer perception. You can think it as a normal neural network, and its ability to understand the periodicity of the data is outstanding. In this paper, there are two main problems. The first one is time series forecasting. What it does is, given an input X, we want to predict the output Y in future timestamps. Another one is time series anomaly detection. Its goal is to analyze the anomaly in the data item in the time series data. In the method of this paper, the first one is dynamic normalization. Generally, we will use the trend sets, mean and standard deviation to normalize all the data, but the data distribution in test set may differ from the trend set, so we need to dynamically alter the mean and standard deviation according to the data input, as we can see here. Let's talk about the model overview. There are two main modules in this MARINA model. The first one is temporal module, which is used to analyze the temporal correlation. Another one is spatial module, which is used to analyze the spatial correlation. In temporal module, what they do is basically given a time series data, we input the data and analyze the correlation by input every timestamps of the data to different neuron and get the MLP output. The second one is spatial learning module. What it do is utilize the attention mechanism to analyze the correlation between different dimensions of the time series data. And as for the result, we can see that MARINA outperformed all the model that is state of the art, including LSTM transformer and traditional time series analysis tool. As for anomaly detection, we also see that MARINA outperformed all the other models like GAN or LSTM or variational autoencoders. In the efficiency part, it can be seen that MARINA performs much better than other models, as we know that transformer requires large amount of data. Also, it requires a lot of time to train. So MARINA outperform all the models on the efficiency and the execution time. In the ablation study, we can see that if we alter the time temporal module to LSTM or other module, it will perform worse, and we can see that MLP is the best choice for temporal module. As for the special module, we can see that using attention mechanism is better for all the data, and we can see multi-layer perception is not useful in analyze spatial correlation. And the last one is the analyze and ablation study on normalization methods. We can see dynamic normalization better captures the tendency of data. As a result, the model performs better than the model using static normalization. This is my presentation. Thanks. 干我讲几分钟啊？差不多了。